All right, guys. Well, good morning, and it's a few minutes after 10:50, so we can go ahead and get started. This is a customer presentation. So my name is Jason Wing. This is Praneeth Kondaveethi. We work at Mostorists Insurance. We're an F5 customer, and we are going to talk to you today about SSO via Okta, SAML, and a custom JSON token. What do you guys think about that title? That's when we were getting this thing put together, we had to fit the title within it. There's only a certain amount of characters that you could use. So we're like, how are we going to explain what we want to talk about? So we had to use a whole bunch of acronyms. So that's why it's kind of a little bit cryptic, I guess. But we're gonna take you through a situation that we found ourselves in. And how F5 helped us get out of that situation. So I'm going to kind of give you some background, some information about Mostorists. PK is going to then walk through some of the technical details. What is that little clicking? I don't know. Okay. So Mostorists Insurance is a regional insurance carrier based in Columbus, Ohio, about 1,300 employees. Sell insurance in about 34 states in the Midwest and the East Coast. Sell commercial lines, which is like insurance for businesses, and personal lines, which is auto insurance, home insurance, and we also sell life insurance. So today we're going to go through, provide some background, explain some of the requirements that we have, explain how we put together an integrated team, our solution, and then PK is going to step through some of the detail that we put into APM, the iRule, some troubleshooting and performance considerations. So on this slide, this is a very oversimplified picture of what our data center looks like to the right of the dotted line. And you see we have our web content management up top. That's what we use for our portal page. That's what our agents will access when they're looking to buy insurance through us. Our authentication services, our backend applications. Basically, this slide is trying to show that we are hosting everything within our data center. We're able to control it, comfortable with managing it, troubleshooting it, administering it. Our independent insurance agent, this is our customer. This is not a Mostorist employee. This is someone that just has an insurance company. They can sell any insurance they want. Our goal is to have them sell insurance through Mostorists. So it's critically important for them to be able to get to our portal page and for them to be able to do all the things they need to do on that page, which connects back to our backend applications. So a few years ago, we made a strategic decision to move to a single backend application, one insurance suite that does everything you need to do for an insurance company. It'll do your claims, it'll do your billing, it'll do your policy administration. It's a system called Guidewire. And so as the organization worked on developing that, or bringing in this big Guidewire platform, we also at the same time found that we were going to leverage a few cloud solutions. So if we all know what's going on with cloud. There's all kinds of options out there, and we leveraged a couple of them. So our app dev team made a decision to move the web content management, which is our portal page, to a hosted solution in Azure, hosted by Episerver. We also, our security team made a decision to move our authentication services to a cloud-based solution to Okta, which is an AWS. Our Guidewire implementation was going to happen on-prem. So we found ourselves in a situation where we had our independent insurance agent. We still need to have them be able to get on the portal page, be authenticated, and have access to our back-end systems. But now we've lost some of that control that you have when you have everything in your data center. So Mostorists had made a very public statement to all of the agents that we were going to provide an enhanced portal page. It was going to be, we had issues in the past. We had heard from our agents, the performance, the experience was suboptimal. So we made a big statement that, hey, we're putting in new systems. We're going to give agents, we're going to give you a good experience. And we had a date. We had a go live date. So it's top priority for the organization. We're working on it. Probably about 4 or 5 months before this go live date, we realized that we did not have an out-of-the-box way to connect our portal page, our authentication mechanism, and our backend applications. We did not have a way to make it so that independent insurance agent would have a single sign-on and would have a seamless experience when they're on the portal page. So so basically we know that our agent is right in the middle of everything. Everything supports the agent. So we knew we had to bring our authentication services, our portal page, and our on-prem data to the agent in a seamless way. We worked on it. The network team tried to figure out the problem. The security team tried to figure out the problem. App dev guys thought they could figure out the problem, but we were just spinning our wheels. And it wasn't until we said, okay, let's get a team together. We call it a diverse integrated team. Let's get all the right people in the room. And let's talk about this. Let's figure this out. So we got our security people, our network people, app dev people, our architects. And we also realized that we didn't have all the subject matter expertise at Mostorists. So we leveraged people from F5. We leveraged from a partner, Nexum. We had an excellent engineer come in from Nexum that subject matter expert in APM. We leveraged an engineer from Okta as well. And we sat in a room and we kind of broke down some of those IT barriers, those barriers between the network team and the security team and things like that. So I'm a Soundgarden fan, so this is hands are for shaking, not tying. Fell on black days. I don't know if anybody's a Soundgarden fan in here. So we talked about this. We whiteboarded. We argued a little bit. We voted, and we finally figured out what we were going to do. And this diagram right here became our approach. So this is our application flow diagram, and this is the cleaned up version of it. So I'm going to hand it over to PK. He's going to step you through the diagram.
Well, thank you, Jason. Before I begin, let me ask you a couple of questions with a show of hand. You can just let me know. How many of you actually worked with SAML on F5? Quite a few. How many of you worked on Okta SAML and F5 integration? You mean the SAML between F5 and Okta? Okay, that's pretty good. How many of you have an idea about what a SAML service provider is? Go ahead. Yeah. Tell me what a SAML provider is.
SAML what?
Service provider is.
SAML is secure access markup, and you like the diagram. You log in. You try to log into an app, and the app says you don't have a current token.
Yep.
It redirects you to the F5 because that application is the service provider. So then it redirects you to the F5, which is in fact the identity provider. And then the F5, in this case, in your case, would go to Okta, which would do the legwork on the back end, log into Active Directory, make sure the credits are good, blah, blah, blah. Give the green light, if you're following your APM flowchart, give you the green light, and then the F5 will return a token to the user, which then he can then successfully log into the application.
That's pretty good. I don't know your name, but you get something. So yeah, I'm going to go through those details while I'm going through the slides in the next of it. Well, so far you have seen how we came up with different requirements and how we brought in different teams into one room to work on this solution and how that led into enormous whiteboarding sessions. So in the next slides, I'm going to show you how we implemented this solution technically from a BIG-IP standpoint. So this diagram right here is a sequential flow and shows you all the components involved in this solution. On the left, on the top left, you can see a user or an agent. Moving to the right, we have Okta for authentication and authorization services. We also have F5 for load balancing, and then we have our Episerver, which is a web content management portal. And finally, the on-prem services. This red box right here shows you one of the two scenarios in this whole solution. Scenario number one, when a user is trying to access resources for the first time. So when a user is trying to connect for the first time, he types in a URL in the web browser that hits the F5. F5 checks if there is a session already existing in the session table, and it didn't find. Let's assume there is no existing session. It's going to use the SAML binding between itself and the Okta and redirect the user for authentication. Once the user successfully authenticates against Okta, Okta posts an assertion to the user's browser. And the user's browser then posts it back to the F5. F5 validates that assertion. And from there, it generates a token using the session information. I'm going to show you how it generates a token in my next slides. Once it does that, it's going to send that token in the header as an authorization to the backend services. Yeah.
So the F5, the first connection, web browser, you're hitting the pip on the F5 on your premises?
Exactly.
Right.
Let's just say, to be specific, in the DMZ, the public-facing side.
Right. But you're not going in either of the cloud services? Web.
No, it's hitting the F5 directly.
Right. That's your bit there.
Yeah.
Question?
Yeah, that's a good question. So once the token is generated on the F5 and when it sends to the backend services decode the token. We base64 encode the token for security. So the application wrote their code in a way to decode the base64 encoded token. Once they decode it, they find the profile information of the agent or the user. Depending on the information in the profile, the backend services are going to allow access to particular resources, depending on the role and responsibilities of the user. And then the F5 reverse proxies the resources back to the user, obviously. Scenario number 2 is when a user connecting, but he's having a existing session. Let's just say a returning user. When a user is already having an existing session, F5 simply checks for the existing session in the session table. Instead of generating a new token, it inserts the same token from the session into the header as authorization and send it to the backend services. And from there, it's the same process. They decode, they find the information, they provide access to the resources. So for all this to work, the solution was to integrate SAML federated services, Okta with F5, to enforce a client-side authentication method. Also use BIG-IP on the grayed out here. Use the BIG-IP to generate somehow an out-of-the-box JSON token. The reason for JSON is it's kind of a standard and what our application teams can actually code into their applications. They cannot do the SAML assertion. They cannot actually decode a SAML assertion in their code. So we need to find a way to create a token using that session information, and we need to use BIG-IP. And specifically, we need to use iRules to create a token using the SAML session from Okta, using some attributes within the session, and create some token and format it to make it look like a JSON token, because F5 doesn't support an out-of-the-box JSON token. So that we call our server-side authentication for more security. Any questions so far? Cool.
Blue box, that's interesting.
Yeah. That's actually the whole interesting part of this presentation. So in a nutshell, the solution would look like we are injecting the SAML attributes from Okta into F5 and coming out as a custom JSON token for a simplified version. So for this to work, we used iRules to generate a token, a custom JSON token, and used APM for the Okta and Okta SAML binding with F5. So in this scenario particularly, we used BIG-IP as a service provider, and IDP is the Okta SAML. Like my friend here explained what BIG-IP service provider is. It's basically one of the AAA services on the BIG-IP that basically requests authentication from the external IDP connector that you specify on the APM itself. So we can bind a service provider with one or more number of IDP connectors. It basically goes to the IDP connector for authentication. And when it receives an assertion from the IDP, it consumes that assertion and provided resources, whatever that is behind the APM. This APM policy, I'm sure many of you already worked on the APM policies, and it's a simple version of it. So this is a simple APM that actually uses SAML binding with F5 and Okta to redirect a user when there is no session found in the session table. It redirects the user for the login, like we talked about in the previous slides. And then after a successful authentication, it's going to run whatever my APM events in the iRule is. Any questions so far? Cool. I know many of you have already seen this page before. This is an APM session variable page where you can find in the APM managed session report. So when a successful session is established on APM, whether it may be SAML or AD, anything, you see a session, successful session between F5 and whatever the authentication party is. You have a active session in your managed session report where you can see the session information in it. So this particular session is APM session for Okta that we received a successful assertion from. Like you can see, we can see a lot of timeouts here. We can find more information like the URL it's hitting and also some attributes and as well as assertion or any kind of authentication we are receiving. This box right here shows a set of attributes that we are receiving from Okta when a successful session is established. Like you can see, we are receiving first name, last name, and few other things about the agent or the user who is trying to log in. And on the right side, these are the exact attributes, the APM attributes, and also the path of it, which we will be using in the iRule to create a token. We're going to reference the exact path to it in the iRules to get our custom JSON token. Any questions so far?
Did you guys use the encryption as well along?
Yes. Yes, we did. So we have our requirements set up. We have an active session we have the attributes we want to use in the iRule. And we started writing this iRule, and this is the iRule that we have in the production today. And to do that, we brought in our professional services partner, Nexum, like Jason said, to help with the iRule. This iRule not only generates the token, it actually also have functionalities of differentiating 15 different maybe applications and send the token depending on the requirement of the application. Some of it needs ICAP scanning. I'm not sure how many of you worked on this. So if one of the application needs an ICAP scanning, we just have to make that only enable for a few of the applications, including sending a token. A few things like ASM, ICAP enable kind of things. And it also does how many redirections we are doing for different applications, like the URI redirection, the basic ones. Since this is a gigantic iRule, I'm not going to go through all of it and bore you with it. Instead, I'm going to give you a sneak peek into the core components of this iRule. So starting with the APM event here. So this block of APM event runs when a successful APM policy is run. So when APM policy runs successfully, I know many of you know, access ACL allowed start to execute. So this block right here looks for a particular variable. Let's just say in this case, it's looking for a JSON that we created. It's a user-defined variable in the session. And if it finds, it's going to insert the same variable, let's just say variable for now, in the header and send it as an authorization. What if the scenario one, the user doesn't have a session and he's coming in for the first time and he got a successful APM session. Now, it runs the else statement here, and we start to set user-defined variables on the left side here with a set command. And we retrieve the APM attributes that I've shown in the APM session variable page by using a data get command. So let me go back a bit here. So these attributes right here are being referenced in the data get command, along with a few other things like we need to, like I said, we need to format the JSON token according to the standards, right? So we need to have a initiation time. We need to have an expiration time of the token. So along with the other few good stuff, we need the actual session attributes from the Okta session. So we do that by using a data get command. Along with that, we also had to use string map. You might already know why we use string map when you want to replace something with something. So we did use string map to remove an extra characters inserted by APM itself. APM inserts pipes when it's an array value. I don't know how many of you tried it before, but if you get something from APM and it's an array value from Okta or any other IDP parties, if you receive an array value, it inserts pipes between each value. So that's an example of why we use string map. So we replace those pipes. There are spaces, there are extra commas, extra columns. We inserted more double quotes to make it look like a key value pair according to the JWT standards. So once we have all this set of user-defined variables, we now have independent values that we need in the variables, in the user-defined variables. But they doesn't make up to the token, right? So we want to create a new variable called JSON and pull all those individual user-defined variables into it as values, and also format it like you can see here. We have inserted some square brackets, some flower brackets here, because, like I said, APM doesn't insert all those necessary things according to the JWT standards, and we want to make it look like a JWT token. So now that we have a JSON token lookalike, we want to insert it as authorization into the header, and we do that by the command right here, HTTP header insert authorization, and we made it proprietary, so MIG is Mostorists Group, and the variable you create. So now we have a I actually forgot to mention this. So we base64 encode the whole token to, for the security purposes. And the backend applications can decode that base64 encoded token. So now that we have a properly formatted, let's say, and base64 encoded token, let's see how it looks when it comes out of the box. The code below is an encoded token, the base64 encoded token from what we created the variable. That exact variable is the actual token we are using in the production today to get the backend services their server-side authentication. I know this isn't pretty, but the decoded version is actually pretty impressive. This is a decoded token out of that base64 encoded variable. This follows the standards of JWT with key value pairs and everything. And this is what our backend services see when they decode that base64 encoded that comes from the FI. They decode it and sees this. And depending on the groups the user belongs to, depending on the agency numbers, and few other attributes here, they provide access to the resources to the users. If that doesn't belong to one of the group, they are not allowed to go to some part of the portal. So things like that. So restricting users based on their roles. Any questions so far?
So when your backend system receives this encoded token, is it running a chunk of code or a sample code or something?
Yes.
So you just install whatever. Does it have? You have to install something from.
So I'm sure that doesn't install anything from Okta, but I'm exactly not sure. But all I can say is I'm not an application guy, so I'm sure they coded their own way to decode a base64 encode. I'm sure they didn't install any plugins from Okta. I'm sure they didn't use any code from Okta. They used their own code. So it's, yeah.
I just want to clarify, Okta provided as the identity provider, provided the SAML token in standard XML format.
Yeah, SAML assertion, that's an XML format.
As long as it does that, then APM can extract all the data in their variables.
Yeah.
And then that's,
Yeah, that's what I've shown in the APM session page. That's what it extracts. And we cannot send the exact assertion or the extracted version because the backend services don't understand the SAML assertion or the pipes, like I said, the format of it. So we have to make it more standardized and more secure. So does that answer your question?
Yeah.
Good. So while we started working on this implementation, we also wanted to see how the troubleshooting would look in a basics perspective. So we use managed session report for the APM sessions. We also correlate those sessions with the user and then the session ID with the APM event logs. The session ID, when you click on the session ID, like you can see here, many of you already use it, it just gives you the information I've just shown. But if you go to the APM event logs, you can see if the SAML actually passed. I'm sure you can also find in the APM's managed session. But with the APM event logs, you find more information. You can see how the APM policy is running, and you can see if it's successful or you have any issues there. Also, we used a lot of local logging, log local 0, many of you already use it, in the iRule to pretty much most of the time they're remmed out to save some of our CPU cycles. But when it comes to the troubleshooting, we unrem them and see if it's generating proper token. Yeah.
I was just going to say, if you wanted to consolidate those logs with your APM logs, you could just go to log one.
That's a good point. I was just referencing log local 0, but we have both kind of logging in there. But thanks for that. Yeah, you get a gift card. I'll give you later. So we use local logging to see if the APM is generating a proper token, and also if the user is getting redirected properly to where they are supposed to, and look for many other aspects of it, and start our initial troubleshooting from there. And fortunately, we never had to troubleshoot deep dive into it. Pretty much it's somebody else's problem, not the network.
It's never the network.
Yeah. So we want to see, since it's a gigantic iRule, we want to see how much of a performance impact it is having on the BIG-IP itself. So until then, I wasn't sure what an iRule editor can do. Did anyone of you use iRule editor before? So it's cool. I wasn't sure I was only writing iRules in it and pushing them to the BIG-IPs. But as you can see here, it actually gives you the CPU cycles of your iRule per each event within the iRule. And along with that, it also gives you the runtime in the latency of milliseconds for each event of the iRule itself. And we figure it's not impacting a lot us because, like you can see here, it's only having averaging up to 0.02 milliseconds for each event in the iRule. Cool, right?
We heard, there was a lot of cautions about, if you use an iRule, especially if it's real long or depending on what it's doing, could it impact the performance of the box? And so this gave us the feel good that, 0.02 milliseconds add. So we felt good going to production with this lengthy iRule.
Yeah, from an F5 standpoint, we weren't worried about the iRule because we write big iRules. But when you have different teams in the room, they want to know if it is impacting something. So this is a cool feature of it, which we found with this implementation. And we also went ahead to see how much of a SSO transactions per second impact it is. So we run a 5250 VCMP guest. We pair of them. They support 21,000 transactions per second. Even with our bridging enabled, it's going to have half of it, which is 10,500, to keep us afloat for a long time. I believe every critical implementations that involves more of these iRules, more of redirections, anything that is BIG-IP overhead specific needs to consider these facts like this that might give you more boost on your work and help you in moving forward. And I guess all I'm trying to say is there has been a lot of hard work and dedication went into this implementation, starting from a thought of moving services into the cloud and writing a complex iRule at the time to enable single sign-on via Okta SAML and custom JSON token. With that said, I'm going to hand over the control to Jason again. Jason.
It's my favorite kind of token. Thanks, PK. This was months of work. So after that initial whiteboarding session, doing the actual work, we got it to the point where, like PK was talking about, what was that last line you had? The string map. So, we didn't have that string map line in there. We're like, where are these pipes coming from? And so you got to troubleshoot that and you got to figure that out. And so PK is like, all right, let's use a string map. Let's take those pipes out. It's breaking us downstream. At Mostorists, the network team has responsibility for the F5. So we had this working before we did any base 64 encoding. That's where the security group is like, hey, you guys don't have any encoding on this. So we're like, all right, well, let's figure out how to base 64 encode. So it was definitely a journey, but we do have this running in production today, and this did allow us to meet that deadline that we were talking about. Yeah.
So we use Okta for different kind of things, but for this implementation, it's just the authentication and the assertion we are receiving from it. We have users both in the AD and in the Okta as well. So we kind of use AD for it, and we create something similar to this, but except the session attributes changes. We use a different, in this case it says session.saml in your session, but when you use an AD, it says session.ad. So that's the difference, but we use Okta for many other things as well. For MFA, say for example. Yes?
So, with Okta, I assume you're using the MFA functions?
Not on this application right now, but we do use for our Citrix. And we also have some POCs going on for the checkpoint and a few others, like the VPN and other things. Yeah. Yeah.
Would F5 at some point, I think they do this, right, as a well-known stable iRule, they will convert that into code, in the software. So is there a plan for them to make that?
Not exactly the JSON token. Not exactly the JSON token, but Jason's going to, that's what he's going to introduce.
2 more
what
slides.
Our next steps looks like.
Any other questions before we move on? What we just described was really what we needed to do to get this in production and working by a certain deadline. But with that lengthy iRule, we knew this was a custom solution. And anytime you have, sorry guys, anytime you have a custom solution, it's not going to be as supportable. It's not going to be as manageable. So we're very interested in utilizing OAuth 2. And we are currently working through that to help us to get a little bit more standardized in the config of the F5, raise our security level, and allow us to manage the box a little bit better. PK, you want to talk some more to this?
So how many of you already installed 13.1 or later code? Okay, good. So it supports OAuth. So like Jason said, we want to move to a standardized approach. Having a custom token is, we cannot support it and we cannot troubleshoot it every time. It's going to be a kind of administrative nightmare when it comes to, a lot of users are trying to access and they all have issues. So we started looking at OAuth. And we are glad that F5 released their newest versions with the OAuth features in it, and I personally love it. And I love the version they released, actually. I don't know how many of you checked out 13.1, but I would suggest you. There are a lot of things that makes your life easier in it. So coming back to the OAuth, so why we want to go with OAuth? Like Jason said, it's an industry standard. The supportability is easier, and the visibility into the OAuth on the F5 is spectacular. Also, obviously, we want to see at the security aspects of it. It supports the introspection from your backend services. I don't know if you know what an introspection is. It's basically your backend services talking to whatever your authorization server is. Let's just say it's an FI. They talk to your FI to make sure the token they received is valid or not. So that's a pretty cool feature. That's more security to your environment. And it does JSON web key rotation. If JWK, JSON web key, is used in your OAuth generation, that you can also do a rotation on it. You can do multiple keys, and they keep rotating depending on the period, I guess. And that enforces more security to it. Also, you get refresh tokens. When you don't want to hand out a token for a long period, like we do today, it's about 3 hours, and you don't want to have a token valid for the 3 hours. You can do a 10-minute token with a refresh token with OAuth. So with a refresh token of 8 hours and an access token of 10 minutes, the user has to renew it, providing his refresh token to the F5 and getting a new token again. That's a lot more security. And there is a token and session validation that you can do. And from an APM perspective, you can do per request, per session validation, which is, like I said, more security again. Coming to the token management of OAuth, it's never been easier. It's on the F5, it's more easier. you can actually look into number of OAuth tokens handed out, number of validations that has done in a period of time. You can see number of refresh tokens that are utilized, and you can actually literally delete a OAuth token if you think it's not legit. So we thought, why not OAuth? So it's kind of a proof of concept that we have in our pipeline right now. Any questions on that? We just don't want to go into the deeper technical details of OAuth. We just want to give you an idea of how a more standardized approach looks like. Any questions? Either we are doing great or we lost you somewhere in the way.
That's pretty much it, guys. And any other questions before we wrap up?
Did you ever test on a VE, and with the iRule complexity, is it any different, you think, in a VE versus on the appliance?
Not so much. The actual POC we did was on a virtual edition. It's almost a 1 millisecond, and when it comes to the physical appliance, it's like 0.02 milliseconds. So, but also it depends on the number of times it run, right? Like you can see in our iRule editor report, it's in the dev region, which doesn't run for so long time. But the production receives a lot of traffic, so probably more latency there.